Hello everyone. Good evening, students. How are you all doing? Hope you're doing good. Students, ఈ రోజు మనం physics లో reflection of light చేద్దాము. All right? So let's get started. Students, reflection of light చేస్తున్నాము where we'll study about a spherical mirror. What is a spherical mirror is? A spherical mirror. All right. So a spherical mirror, which is a part of a sphere, it's called spherical mirror is a part of a sphere, students. The yellow shaded region is the spherical mirror. Center of that sphere is called center of curvature of the mirror. Let's talk about concave mirror, students. ఇప్పుడు concave mirror చూద్దాము. Concave mirror చూసాక ray diagrams చూద్దాము. And then we'll go for convex mirror ray diagrams. Then we'll go for some problems and questions. Questions and problems. All right. So let's get started with concave mirror. These lines are drawn to represent the painted surface. Ante right side is the painted surface, left side is the reflective surface. The radius r of the sphere, of which the spherical mirror is a part, is called radius of curvature of the mirror. Center C is called center of curvature. Point P, which is center of the mirror, is called pole of the mirror. Line joining the center C and the pole is called principal axis. All right. These terms are very important, students. These terms మీరు గుర్తుండాలి. Let's look at the ray diagrams for now for concave mirror. All right. So ray diagrams for students. Concave mirror ki కొన్ని cases ఉన్నాయి, but convex mirror ki simplest case ఉంది. At this level, our object will be in front of the mirror. మన ఆబ్జెక్ట్ ఎప్పుడు మిర్రర్ కంటే ముంగట ఉంటుంది. Let us say there is a ray parallel to principal axis, hits the mirror, reflects and passes through a point called focus, principal focus of the mirror, F. Now, a ray passing through focus and incident on the mirror, passing through focus and incident on the mirror will get reflected parallel to the principal axis of the mirror. All right. So first was a ray parallel to principal axis. After reflection, passes through principal focus. A ray through principal focus, after reflection, will pass parallel to the principal axis. A ray through center of curvature, incident on the mirror, will hit the mirror perpendicularly because there's a radial line. Center of curvature on the mirror varaku radial line undi. Radius is perpendicular to the mirror here. So this ray will hit the mirror perpendicularly. If it hits perpendicularly, it will rebound perpendicularly. So after reflection, it will retrace the path. The reflected ray retraces its path. Okay. Okay, Nitin is here, Srinitya is here, Nidhi is here, Ramcharan is here. All right. Good. You can interact, students. Any questions or any query you've got, you please put in the chat box, but I'll continue with the concept. When the ray hits the pole of the mirror, P, when the ray is incident on the pole of the mirror, it gets reflected in such a way that it's symmetric with respect to principal axis. Ante, the angle theta is equal to angle theta made by the incident ray is equal to angle theta made by the reflected ray with the principal axis. Now, out of these four rays, we can use any two rays to trace the image of the object. Manaki two rays sufficient, students. Intersection of two rays is the image. So any two rays of these out of these four rays is sufficient for us to trace the image of any object in front of the mirror. All right. So let's get started with image tracing, ray tracing. These were the rules for ray diagrams. Now let's apply these rules to trace the image of the object, given object. Students, there is a yellow color arrow, which is the object in front of the mirror. We have to trace this image of the object. So we'll use a ray. First ray is parallel to principal axis. We can use any of the 4 rays we discussed. So we first use principal axis, ray parallel to principal axis. When reflected, will pass through focus. A ray through focus, after reflection, will pass parallel to principal axis. Intersection of these 2 yellow rays is nothing but the image. Inverted image we get, real, inverted, and diminished. Okay, now let us move the object little closer to the mirror, students. కొంచెం దూరం ఉండే మిర్రర్ కి కొంచెం క్లోజర్ తీసుకెళ్దాం. ఇంతకు ముందు కొంచెం దూరం ఉండే, ఇప్పుడు సి కి దగ్గరకు వచ్చింది. సో ఇట్ హస్ కమ్ క్లోజర్ టు ద మిర్రర్. మిర్రర్ కి దగ్గరకు వచ్చింది. All right. Now let us trace the ray and form the image. Let us find where the image is formed. Again, I'll choose the first ray to be ray parallel to principal axis. I can choose any 2 rays, students, but I'm choosing these 2 rays. All right, bit convenient. We choose ray parallel to principal axis. After reflection, it pass through focus. Ray passing through focus, after reflection, will pass parallel to the principal axis. Intersection of these 2 yellow reflected rays is nothing but the image. The red color arrow, inverted arrow is the image. The real image is formed where the reflected light rays meet. All right. So, students, that's still inverted, real, and between C and F. When the object is beyond C, beyond center of curvature, my image is lying between focus and center of curvature. Right. These facts you have to remember, students. But remember the ray diagram. You should be able to visualize the ray diagram. రే డయాగ్రామ్ మీకు మైండ్ లో రావాలి స్టూడెంట్స్. మీరు ఏ ఆబ్జెక్ట్ మిర్రర్ చూడంగానే మీకు రే డయాగ్రామ్ మైండ్ లో రావాలి ఫస్ట్. రైట్, నెక్స్ట్ ఈక్వేషన్స్ విల్ బి ఫాలోయింగ్ లేటర్. బట్ రే డయాగ్రామ్ ముందు వస్తే, ఇఫ్ యూ ఫాలో ద రే యూ విల్ ఫైండ్ ద వే. మీరు రేని ఫాలో చేస్తే మీకు దారి దొరుకుతుంది, సొల్యూషన్ వచ్చేస్తుంది ఆటోమేటికలీ. రైట్, నౌ let us move it further closer to the center of curvature, to the mirror. Inka close move cheste, let us see where the image is formed. Where do you think the image is formed, students? Can you type in the chat box? Ekkada form avutundi image? It is beyond center of curvature. So where do you think the image is formed? You can please type that in the chat box and let me know. Image ekkada form avutundi cheppagలుగుతారా? Chat box lo type chesi cheppandi. Whether it is between F and C, between F and P, beyond P, behind the mirror. Yes, good, Nathan. Excellent. It's between F and C. Okay. Nidhi, Ramcharan, Mohammed, Mujib. Yes, Nathan, good. Okay, there is another student by name, name is not clear. Would you please mention your name as well? About mathematics? Yes, Aditya, okay. It's not at C, students. Object is not at C. That's the next case. Already put చూద్దాం, రే డయాగ్రామ్ డ్రా చేసి చూద్దాము. I'll choose a ray parallel to principal axis that will pass through focus after reflection from the mirror. A ray passing through focus will pass parallel to the principal axis. Intersection of these 2 rays, reflected rays, is nothing but the image formed. Inverted red arrow is the image formed. This is again between F and C, as you all said. That's good. All right, Anjali, that's good. But observe one thing, students, that object is being moved towards the mirror, closer to the mirror. Image is going away from the mirror. Object ని మిర్రర్ కి దగ్గర తీసుకెళ్తే ఇమేజ్ ఏమో దూరం వెళ్తుంది. ఇంతకు ముందు ఆబ్జెక్ట్ దూరం ఉండే, ఇమేజ్ వాజ్ నియర్ ఫోకస్. ఆబ్జెక్ట్ సెంటర్ ఆఫ్ కర్వేచర్ కి దగ్గర వచ్చింది, మిర్రర్ కి దగ్గరకు వచ్చింది. ఇమేజ్ ఇస్ గోయింగ్ అవే ఫ్రమ్ ఫోకస్, దట్స్ గోయింగ్ అవే ఫ్రమ్ మిర్రర్. It's going towards center of curvature from right, it's going away from mirror. So observe that object is moving towards the mirror, the image is going away from the mirror. All right. Now let us keep the object exactly at center of curvature. Now this is what Srinitya was talking about. Center of curvature దగ్గర పెడితే we choose the ray parallel to principal axis. On reflection, this goes through focus. That's fine. The ray through focus will go parallel to principal axis. That's also fine. Intersection of these two reflected rays, yellow rays, is nothing but the image formed. Inverted red arrow is the image. Note that X, yes, Nitin is right. Anjali is right. Yes, good. Nidhi is right. Lokesh is right. Excellent students. Your concepts are really good. Your memory is good. But be careful that we are trying to revise the ray diagrams here. మీకు ఆబ్జెక్ట్ ఇంకా మిర్రర్ చూడంగానే రే డయాగ్రామ్ విజువలైజ్ అయిపోవాలి. ఆల్రైట్, దట్స్ ద టార్గెట్ ఆఫ్ అవర్ సెషన్ టుడే. దాని తర్వాత క్వశ్చన్స్ చేస్తాము, దాని తర్వాత న్యూమెరికల్స్ చేస్తాము. ఆల్రైట్, బట్ రే డయాగ్రామ్స్ మనం రివైజ్ ఎందుకు చేస్తున్నాము? సో దట్ యువర్ విజువలైజేషన్ ఆఫ్ ద రే డయాగ్రామ్స్ ఇస్ వెరీ యూఆర్ కంఫర్టబుల్ ఇన్ ఇట్. ఈజీగా విజువలైజ్ చేయగలాలి. ఆల్రైట్, నౌ లెట్స్ సీ. Observe that image and object are at the same point, inverted. Let's see itself. Now let's move it. Let's move the object further closer between C and F. Now where do you think the image is formed, students? Now where do you think it's formed? Yes, Anjali, you are absolutely right. We get the same size image at C. But in this case, when the object is moved closer to the mirror, image is going away from the mirror. C దగ్గర ఉంటే C మీదనే వచ్చింది. C కంటే దగ్గరకు వచ్చింది మిర్రర్ కి. So image will go away from the mirror. Let's see how do we trace this. You choose a ray parallel to principal axis. Ray passes through focus. Another ray through focus will pass parallel to principal axis. Look at this, students. It's magnified now. Anjali, you said it's the same size at C. It's magnified now beyond C. Excellent. Aditya, Lokesh, Nidhi. All right. Chandra, object ఇక్కడ ఉంది. Repeating in a minute. Object ఇక్కడ ఉంది. Please mute yourself. Please mute yourself. Students, please mute yourself. All right. Sorry for the disturbance. All right. So object is in front of the mirror between F and C. Now, if I take the ray parallel to principal axis, reflected ray passes through focus. When I choose a ray through the focus, it will get reflected parallel to the principal axis. Intersection of these two yellow rays is again the image. Look at this. Image is formed beyond C, as you all said, and enlarged. Inverted, real, and enlarged beyond C. Observe that object is moving towards the mirror, image is going away from the mirror. Now let us keep the object at F. Students, follow this carefully. We are keeping the object at F. Now what do you think would happen, students? Now what do you think would happen? Students, you're all right. You will enjoy the session today because there are going to be a lot many questions. Yes, Lokesh, you are absolutely right. At infinity, let's see the ray diagram. Yes, Nitin. I choose a ray parallel to principal axis, that's fine. That will pass through focus, that's okay. But the other ray I choose is a ray hitting the pole of the mirror. We choose a ray incident on pole, it should get reflected making same angle with the principal axis. Pole ki hit చేస్తే ఇలా వస్తుంది. ఇది theta అనుకుంటే కిందది కూడా theta ఉంటుంది. If the angle with the principal axis of the incident ray made by the incident ray is theta, angle made by the reflected ray with the principal axis is also theta. So the rays meet at infinity, reflected rays meet at infinity, hence real, highly enlarged inverted image is formed at infinity. Right, you're all right again. Anjali, Aditya, Mujib, Nitin, Niti Gupta, Gauze, Lokesh, excellent. Now look at this. I am keeping the object between focus and pole now. Okay. The object is between focus and pole. Again, I can choose any of the four rays which we have discussed in ray diagram, ray tracing. One ray, brilliant. Before I do, you have done it. Nitin, it's behind the mirror. Brilliant. Let's look at the ray diagram. We choose a ray parallel to principal axis that will pass through focus of the mirror, principal focus of the mirror. The other ray would be incident at the pole of the mirror that will get reflected symmetrically with respect to principal axis of the mirror. When I trace these rays backward, I get the image formed here, behind the mirror. Excellent. Lokesh, Anjali, Nitin, Nidhi, Gauss, Mujib. Excellent. Surely, you're all doing so good. But only thing is, if at all you're not visualizing the ray diagram, adi tappu. రే డయాగ్రామ్ మీరు విజువలైజ్ చేయగలగాలి. రైట్, ఆన్సర్ యూ మే రిమెంబర్, మీరు గుర్తు పెట్టుకోవచ్చు, బట్ రే డయాగ్రామ్ కూడా మీరు విజువలైజ్ చేయగలగాలి. రైట్, లెట్స్ గో ఫర్ ద నెక్స్ట్ వన్. A virtual image is formed behind the mirror. Now let's look at convex mirror. Alright, we are done with concave mirror. Convex mirror చూద్దాం students. Convex mirror లో painted surface, the inner surface is the painted surface and the outer is the reflective surface. See center of curvature as before. Center of the sphere is nothing but center of curvature. Yes, Aditya, Pavan, Gauss, Lingaya, Lokesh, Anjali, Nitin, you're all doing so good. Here's the pole of the mirror. Line joining principal pole and center of curvature is the principal axis of the mirror. Now the rules are a ray parallel principal axis incident on the mirror will get reflected such that it appears to come from a point called focus. The ray is reflected such that it appears to come from a point called focus. All right, when I trace this backward, when I extend the rays reflected ray backward, that will pass through focus. That's called principal focus. Other ray would be a ray hitting the center of curvature. Ray directed towards the center of curvature, incident on the mirror, will hit the mirror perpendicularly. Thus directed towards center of curvature, that will get reflected such that it appears to pass through center of curvature. All right. Yes, Anjali, we are going to do electromagnetism also. We'll do whole of physics, whole of physical science, biological science, mathematics as well. All right. So we're going to do every chapter. Don't worry. But yeah, that's good you asked. We'll definitely do it. If you have got any specific doubts, you please put it. We'll address all those doubts. Any doubts clarify chestamu. All right. Okay. Let's go forward now. These two rays are sufficient for me to trace the image of the object. ఇప్పుడు చూద్దాం ఇమేజ్ ఎక్కడ ఆబ్జెక్ట్ ఎక్కడ పెడతాయి, ఇమేజ్ ఎక్కడ ఫామ్ అనేది చూద్దాము. Anjali, Lingaya, you are absolutely right. Aditya, Gauss, Lokesh, Nitin, absolutely right. Let's keep the object over here. No matter where the object is, let's see what happens. We choose a ray from the tip of the object parallel to principal axis that gets reflected passing through, as if passing through focus when extended backwards. From the tip of the object directed towards center of curvature, that will get reflected perpendicularly to the mirror. It is incident normally, it will get reflected normally. When the rays appear to meet, the image is formed. It should be drawn as dotted line as it is a virtual image. All right, that's why I'm drawing it with a dotted line. So object, when it's front of the mirror, image is formed between pole and focus of the mirror. As you all said, that's perfectly right, that no matter where the object is, image is formed between the pole and focus of the mirror. And diminished, virtual, diminished, and erect between pole and focus. All right. So students, this is all about ray diagrams. Ray diagrams, your answers are absolutely apt, appropriate, correct, perfect. Now let's go for some questions. Questions and the numericals. Are you all ready for that? Yes, Aditya, you're absolutely right. That's good. Students, your interaction is highly appreciable. Very good. Chala baga chestunnaro. Let's go for questions. Are you all ready for the questions now? Okay, let's go forward. According to sign convention, the distance which is measured in the direction of the incident light to be taken as positive, negative, no sign, any sign. Yes, Anjali, you are absolutely right. But answer this question now. Is it positive, negative, no sign, or any sign? According to sign convention, the distance which is measured in the direction of incident light is to be taken as, okay, Swati is here. Swati says positive, Anjali says positive, Lokesh says positive, Nitin says one positive. Brilliant. Everyone is answering the absolutely giving the absolutely right answer, which is positive. Yes, let's go for the next one. The rays coming from source parallel to the principal axis of a concave mirror converge at a point. This point is called principal axis, focus, center of curvature, pole. Yes, Aditya, Mujib, Nitin, Lokesh, Anjali, Swati, absolutely right. Gauss. Yes, Swati is correct. Pavan is correct. Aditya Pavan is correct. Anjali is correct. Lingaya is correct. Aditya is correct. Brilliant. Let's go for the answer key, and that is focus. Yes. Rays from a source parallel to the principal axis of for a concave mirror converge at a point which is called focus. For a convex mirror, they appear to diverge from a point which is called focus. All right. In concave mirror, they converge. Concave mirror converge, I think, actually. Convex mirror, no, they appear to diverge from a point, and that's called focus. In case of plane mirror, the object distance is dash to image distance, equal, lesser, greater, none of these. In case of plane mirror, the object distance is dash to image distance, equal, lesser, greater, none of these. Good. Nitin says 1, Aditya says 1, Swati says 1, Lokesh says 1, Nidhi says 1. Yes, Girl says 1, Anjali says 1, equal. Aditya says equal. All right. Good. Let's see the key. It is equal, students. For plane mirror, object distance and image distance are equal. Image ఎంత దూరం ఉంటుంది, object కూడా అంతే, object ఎంత దూరం ఉంటుంది, image కూడా అంతే దూరం ఉంటుంది behind the mirror. For a real object, for an object in front of the mirror, image is behind the mirror. Magnification is always 1 for the following mirror: convex mirror, concave mirror, plane mirror, none of these. Students, ఇలాంటి questions when you target TSRJC, Polycet, చాలా అవసరం పడతాయి students. We are not just revising the concept, we are also getting ready for competitive exams. Competitive exam ki unna kavalsina strategy is different from usual board exams. We are revising 10th class syllabus. We are revising concepts of whole of 10th maths and science. At the same time, we are also getting ready for Polycet, TSRGC, PSWR, all such type of competitive exams. All right, plane mirror. Yes, it is plane mirror. That's brilliant. Magnification is 1 for the following mirror, always 1 for the following mirror. It's plane mirror. The height of the image is double the size of the object. Its magnification is height of the image is double the size of the object అంటున్నాడు. Object size x అనుకుంటే image size is 2x. Excellent, Anjali. Your reasoning is absolutely right. Be careful, students. ఇక్కడ 1/2 కూడా ఇచ్చారు, 2 కూడా ఇచ్చారు. But height of the image is double the size of the object అంటున్నాడు. So what do? It's 2. How is it 2? Height of the object x అనుకుంటే HO, height of the image HI is 2x అనుకుంటే magnification is nothing but HI by HO, which is nothing but 2x by x. X gets cancelled out, which is 2. Yes, Nitin, Aditya Pavan. Sri Vanilla, Gauss, Nidhi, all of you are right. All of you are right. Good, excellent. Let's look at this one. A person is standing in front of a plane mirror at a distance of 10 centimeters. All right? 10 centimeters దూరంలో ఒక person is standing. He walked 4 centimeters towards the mirror. The distance between the object and the image in the second case is 10 centimeters, 12 centimeters, 6 centimeters, or 8 centimeters. Students will do all the topics. Please do not worry. Electromagnetism కూడా చేస్తాము. EMI is one of the finest and most difficult topics in whole of physics. 10th లోని కాదు, advanced physics లో కూడా EMI, electromagnetic induction, is one of the toughest topics. So we'll do it in detail. So don't worry about anything. Nothing will be left behind. Nothing will be left out. Okay. He's saying distance between the object and image, not object and mirror. Nitin, Nidhi, your answer is right for the question when I say distance between object and mirror. Anjali, think again. Aditya, think again. Gauss, think again. Mujib, Nidhi, please think again. Image or mirror ఇలా ఉంటే ఆబ్జెక్ట్ ఇలా ఉంది, 10 centimeters దూరంలో ఉంది, 4 centimeters దగ్గరకు వచ్చింది. 6 centimeters is the distance between object and image in the second case. But he's saying object and image in the second case. Object ఇక్కడ ఉంటే image ఇక్కడ ఉంటుంది. This is 6 centimeters, this is 6 centimeters. Total is 12 centimeters. All right. It's 12. Initially, 4 దగ్గర ఉంది. Sorry, 10 centimeters దూరంలో మిర్రర్ నుంచి 10 centimeters దూరంలో ఉంది. 4 centimeters దగ్గరకు వస్తే distance between the object and the mirror is 6 centimeters. So distance between the object, mirror and the image is also 6 centimeters. So distance between image and object is 6 plus 6, 12. Yes, Nidhi, you're absolutely right now. Anjali, Nidhi, Swati, Sri Vanilla, absolutely right. Good, Gauss. All right, let's look at the next one. An object is 24 centimeters away from concave mirror and its image is 16 centimeters from the mirror. Find the focal length of the mirror. We use the mirror equation for the students. Object distance ఇచ్చారు, image distance ఇచ్చారు. What is required is to find the focal length of the mirror. Yes, Anjali, you're absolutely right. Okay, now for this, you will have to go for the equation, students. Without equation, you cannot solve it. I'll give you a minute. Okay, let's see. Please calculate. Don't go wrong in calculation, students. I'll reveal the answer now. It's 9.6 centimeters, students. Let's see how. Object distance is 24 centimeters given. Image distance is 16 centimeters. Required to find the focal length. Okay, answers are pouring in. I would like to go forward, students. Okay, Aditya has an answer. Others, please try. Yes, Aditya is absolutely right. Aditya Pawan is right. All right, let's look at the next one. Yes, Anjali, you are absolutely right. There is a sign convention here, but let me just look into it. Uh, Sign convention is required, students. Object distance is negative here, minus 24. Let me just solve it. Sign convention compulsory apply cheerly, students. As Anjali asked, said, you have to apply sign convention. You cannot solve the problem. It is wrong to solve the problem without sign convention. So I've got the mirror here, concave mirror elongate. Object is in front of 24 centimeters away from the mirror, concave mirror. Students, image is 16 centimeters from the mirror antenna. Right. So let's say this is my F, this is my C. And let us say find the focal length. It is possible when object is here and image is found somewhere here. Only then this is less than this. When it's beyond center of curvature, only then the image distance is less than the object distance. So I'll have 1 by minus 24 plus 1 by minus 16 is equal to 1 by F. Solve this, you'll get the answer. Okay, okay. I'll just change the color, students. Just give me a minute. Give me a second. Yeah. So I've got 1 by F is equal to 1 by U plus 1 by V. U is minus 16. V is minus 24. Substitute these values, you get value of F. All right. All right. Uh, okay. Now let's find out this answer this question. Find the nature of the image formed by an object placed at a distance of 15 centimeters from the concave mirror of focal length 10 centimeters. Nature of the image is what is to be found. Nature of the image కనుక్కోవాలి స్టూడెంట్స్. ఆబ్జెక్ట్ డిస్టెన్స్ ఇచ్చారు, ఫోకల్ లెంగ్త్ ఇచ్చారు. సో ఇఫ్ యూ ఫైండ్ అవుట్ యూ, even without finding out you can do it, because he's not asking for any numerical answer. He's just asking the nature of the image. ఎలా చేస్తారు? For everything it first draw the mirror. ఫోకల్ లెంగ్త్ ఇక్కడ ఉంది 10, center of curvature 20 ఇక్కడ ఉంటుంది. Object is here. So image will be beyond center of curvature and enlarged. Real, inverted and enlarged. So 2. Sri Mandela. Swati is absolutely right. చూడండి, నేను ఇక్కడ ఈక్వేషన్స్ సాల్వ్ చేయట్లేదు. నేను జస్ట్ ఆబ్జెక్ట్ ని ప్లేస్ చేశాను మిర్రర్ ముంగట. ఇక్కడ చేశాను 10 ఇంకా 20 మధ్యలో చేశాను. 10 ఇంకా 20 మధ్యలో చేసినప్పుడు దట్ ఈస్ బిట్వీన్ ఫోకస్ అండ్ సెంటర్ ఆఫ్ కర్వేచర్. సో ఇమేజ్ ఫార్మ్ బియాండ్ సెంటర్ ఆఫ్ కర్వేచర్ అండ్ ఇన్వర్టెడ్, అది చూసాం మనం రే డయాగ్రామ్స్ లో. సో ఇట్ ఈస్ ఇన్వర్టెడ్ అండ్ రియల్. ఆల్రైట్, దట్స్ గుడ్. అంజలి, నితిన్, ఆదిత్య, Gauss, Arvind, Mujib, brilliant. Let's go forward. To get image larger than the object, one can use a convex mirror but not concave mirror, a concave mirror but not convex mirror, either convex mirror or concave mirror, a plane mirror. To get an image larger than the object, దేంట్లో వస్తుంది? In which mirror is this possible? Convex mirror, we have seen it, it is always diminished, magnified. Magnified radu. Alright? For the cases we have studied, for the cases which is there for this R syllabus at this 10th level, manaki object mungatunte, convex mirror mungatunte, image is always minified, diminished. Direct, virtual and diminished. Magnified approach stundi only with possible with a concave mirror. Yes, Swati, Pavan, Mujib, yes, you're all right. Sri Vanilla, that's good, brilliant. Yes, there's option 2. Concave mirror possible, but not in convex mirror. We have seen it. Concave mirror law, except at center of curvature, when the object is within center of curvature and mirror, between center of curvature and pole, image is magnified, inverted. When it's between pole and focus, magnified and erect, but virtual. Alright, so magnified cases concave lone possible undi, convex lo possible ledu. Alright, let's go for the next one. If the magnification of the mirror is greater than 1, then the mirror is concave, convex, plane, none of the above. Students, if you want me to go slower, you can tell me, or if you want me to go faster, you can tell me. But here, the intention is that you should understand what I'm speaking. మీకు అర్థం అవ్వాలి, నేనేం మాట్లాడుతున్నాను మీకు అర్థం అవ్వాలి. It is for your good, it's for your benefit. Okay, Swati is right. Go ahead, others please punch in your answers, quick. Sri Manala is right, Nitin is right. Yes, Arvind is right. Yes, Nitin. Anjali is right. Nitin Gupta is right. Good. Excellent. It's concave mirror. Let's go for the next one. Focal plane of a spherical mirror is. He's talking of focal plane, students. Focal plane. Line joining pole and focus of the mirror. No. Plane perpendicular to principal axis at focus. Plane perpendicular to principal axis at center of curvature. Plane parallel to the principal axis. So focal plane antunnadu. So first one is definitely ruled out. He's talking about line. 2, 3, 4 lo plane undi. So we have to figure out between 2, 3 and 4. Yes, Anjali, you can surely have Zoom link. Okay, you want to join in the Zoom link? Anjali, you can surely have Zoom link in the that's there in the group. I'll have to speak to the team students. All right. Yeah, look at this. Second option. Nitin says second one. All right. It is true. Absolutely right. Plane, which is perpendicular to the principal axis at focus, is focal plane. When a set of parallel rays of light inclined at 15 degrees to the principal axis are incident on the convex lens. All right, we are moving to lenses now. Students, we'll do one thing. Lenses, refraction, we'll do it in another session. Any doubts so far? If at all you've got any doubts, you please message. Yes, Gauss, Arvind, Nithi, Swati, Anjali, Nitin, Sri Vanilla, Arvind, you're all right. Perfectly right. Sri Nitya, brilliant. But students, uh, so as of now, let us move on to the next session. Yes, Anjali, which is that you want me to explain, Anjali? I didn't get your question. What is that you want me to explain briefly? Okay, okay, I'll explain. Look at this. I've got the concave mirror now. It is focus. Double the distance, center of curvature. This plane perpendicular to the principal axis, passing through focus. This focal plane. రైట్ ఫోకల్ ప్లేన్ గురించి మళ్ళీ మనం రిఫ్రాక్షన్ లో వెళ్ళినప్పుడు కొంచెం డీటెయిల్ గా మాట్లాడతాము. మరి రిఫ్లెక్షన్ లో అంత డీటెయిల్ గా మాట్లాడాము. రిఫ్రాక్షన్ లో కొన్ని ప్రాబ్లమ్స్ చేశాము, స్టూడెంట్స్ పెట్టాము సెషన్ లో. సో ప్లీజ్ హ్యావ్ పేషెన్స్. యూ విల్ అండర్స్టాండ్ వాట్ ఇస్ ఫోకల్ ప్లేన్ ఇన్ రిఫ్రాక్షన్. లెన్సెస్ అయినప్పుడు యూ విల్ హ్యావ్ సమ్ క్వశ్చన్స్ ఆన్ దాట్. యూ విల్ అండర్స్టాండ్ ఇన్ బెటర్ వే. రైట్. Alright. So students, I request please stay tuned. Any doubts you've got, you please message. We'll address all those doubts. We'll design our session in a better way so as to address your doubts. మా సెషన్ ఎలా డిజైన్ చేసి ప్రెజెంటేషన్ ఎలా డిజైన్ చేసి మీ డౌట్స్ క్లారిఫై అయినట్టు చేస్తాము. All right. So let's continue in the next session, students. Thank you all. Thank you all for joining me. Good night and good luck.